Okay, so for this video, I'm just going to talk briefly about problem 2 and problem 3 from the exam. So the first one, I'll walk you through my steps, and you can see them, but I'll kind of give my justifications. So the reason I moved the 1 to the other side is the most straightforward way to simplify this problem is to get rid of this radical. And the best way to get rid of the radical is to make sure it's on a side by itself and then be able to square. If I square while it has some other term on the same side as it, then I'm going to continue to get that central term that's going to have a radical. So it won't really do me any good unless it's by itself. So I go ahead and isolate the radical, then I'm going to square it. Now I keep in mind that anytime I square a square root, I'm introducing problems, because if I had the negative square root and squared it, I'd still get 2x plus 1, and if I have the positive root and square it, I get 2x plus 1. So I know I've kind of simplified some things here. Then I need to note that if I square my left side, I have to square the right side. So I get x squared minus 2x plus 1. Remember, that's the proper way to square a binomial. And then I move everything to one side, and I get 0 equals x squared minus 4x, which I can then factor into x times the quantity x minus 4. Now I use that zero property principle that says if I have zero product principle, that if I have a product and that product equals 0, then one of the factors must have been 0. So then I can set those two equal and say, well, 0 or x must equal 0 or x minus 4 equals 0. So I have two possible solutions, 0 and 4. So remember I talked about this step, how I introduced some problems, so I need to check to make sure what happened. So I put in 0 here, I get 2 times 0 plus 1, that's going to be 1, so the square root of 1 is 1, plus 1 gives me 2, and 2 is not equal to 0, so I know something happened here. Right? So I had an issue, so I need to exclude that. That was an extraneous solution. And the reason that is because if this were a negative root, then I would have gotten negative 1 plus 1, and that does equal 0. And the fact that that negative root could have been here but wasn't is where that extraneous solution came from. And in the same way I tried over here, I put in my 4's in my original problem where I had x's. So I put in 4 here. That gives me the square root of 9, which is 3, so 3 plus 1 does equal 4, so then this is a legitimate solution. So x equals 4 is a good solution. Alright, so part B is a little bit tricky. Here's one way to do it, but this is not probably the best way or the neatest way, but if you thought maybe I'll try to factor something out, this is one way you could have approached that. The other way is to notice that 1/4 is a smaller power than 1/2. In fact, 1/4 is half of 1/2, right? So if I replace x to the 1/4 with some other value, call it a, then here where I had 2x to the 1/4, now I have 2a. You see that here? And then I have my minus sign, which I have here. And then if a is x to the 1/4, then I know if I squared x to the 1/4, I'd get x to the 1/2. So if I see x to the 1/2, that's the same as an a squared. Okay? And now this is easy enough to factor. So I have these two factors, they're set equal to 0, so I can break each factor and set each factor individually equal to 0, so that simplifies my job a little bit. So I see that a equals 0 or a equals 2. Okay, and then I remember that originally I had x to the 1/4 instead of a, so I substitute that back in. So x to the 1/4 equals 0. Well, if I take x to the 1/4 and raise that to the 4th power, then I just get x, and 0 to the 4th power is still 0, so I get x is equal to 0. In the same way, if I have a equals 2, that's the same as x to the 1/4 equals 2. Well, if I raise both sides to the 4th power, then I get from x to the 1/4 to the 4th power would then be x, and 2 to the 4th power is 16. So now I have those two solutions, 0 and 16. All right, for the last problem, you can do it a couple different ways, but the thing to keep in mind is that our solution asks, our question asks, how long will it take the second car? So my answer needs to be in terms of how long the second car is going, the time of the second car. So I'm dealing with some rates like kilometers per hour, I'm dealing with some times like hours, and I want to know, and I know some distances, or kind of know some distances. I know that the second car and the first car are going to drive the same distance, and that's going to be key in a moment. So I can set up a table like this, where I have rate times time equals distance. Now you could have set, well, let's start with the rates. The first car is leaving at a rate of 30 kilometers per hour, so I put in my 30 here. The second car, 38 kilometers per hour. So these are pretty straightforward. Now the times we don't know. In fact, that's what we want to know. I always recommend putting your simplest variable for the thing that you're looking for. So in this case, I'm looking for the time of the second car. So I put t as the time of my second car. Then I know that the first car, since it left 2 hours before the second car, must have been driving for the time of the second car plus 2 more hours. So I had the t plus 2. And then since I know the relationship between rate and time and distance, I know that I can say, for example, 38 kilometers per hour times t hours would give me 38t kilometers. So I know how far this car went relative to its time, and in the same way I can multiply 30 times t plus 2, and I get this distance. And then the key insight is, if the second car catches the first car, then they've traveled an equal distance, and so I have my two distances set equal to each other. I distribute the 30, adjust for my, notice that the right hand side has 8 more t's than the left hand side. So here I have 60 equals 8t, divide by 8, and I know that my time was 7.5 hours. And that's the part that I was looking for. If you had set this for t, the first car, you would have found 5.5 hours, or sorry, 9.5 hours, and you would have needed to subtract 2 hours.